The second topic of this lesson is just solving equations that involve trigonometry. So first off, when we're solving trig equations, we need to use the inverse, sine, cosine, and tangent functions, which should not be confused with the reciprocal trig functions. Reciprocals are flipping fractions. The inverse trig functions undo and get rid of sine, cosine, or tangent. So here, for example, when I have sine of x equals 1/2, the thing that will remove sine completely, not just canceled out with a fraction, is the sine inverse function. So we take the sine inverse, which is why you see that -1, just like f inverse of x, but both sides. So this cancels, and then x equals whatever the sine inverse of 1/2 is. So we're going to be doing this in degrees, so I'm just going to make sure my mode is in degrees. And then I do second sine, that's sine inverse of 1/2. And that gives me 30, which shouldn't be a surprise, right? Because we know the sine of 30 is 1/2 from the chart. Now, the question is, why is it necessary to specify a range of possible values for x? Well, now that we know about the unit circle and the quadrants, we know that there's many places where sine equals 1/2. If you think about a sine graph, right, it goes up and down and it crosses 1/2 many times. So there's actually an infinite number of answers. Your calculator is only going to give you one on a certain range of values, but there are other answers, which we're going to see in the next problem. So in the next one, now we're going to solve for sine of x equals 1/2 for 0 to 360. So we kind of start the problem the same way. I'm going to write that down. So we do our sine inverse, and we're still going to get x equals 30. But then we want to think about ASTC. So when we think about sine being a positive number, because sine is positive, it's positive 1/2, that means I have an answer in the first and second quadrant where sine is positive. So as our calculator is a function calculator, so for each input, for each, we plugged in 1/2 to the sine inverse function, it's only going to give me one output, in this case 30, but I need to think about the fact that there are other answers. So I put down quadrants 1 and 2, because that's where my answers are going to be. Now, 30 fits in quadrant 1. We know 30 is in quadrant 1. But over here, there's another triangle just facing in another direction that also would have the same values as 30. So if this is 30, this is also 30, but we know this is 180. So 180 minus 30 means that this angle is 150. So the way we find that is basically we use our reference triangles and reference angles, figure out what quadrant we're in, and put the angle into that quadrant. So the two answers between 0 and 360 are 30 and 150. If I didn't give a range, I could keep going around the circle. So if you think about it, if you went all the way around the circle back to 30 degrees, I would have 390, right? And I could keep doing that. So usually we restrict our angle answers to just one rotation, or 0 to 360. So here are a couple other versions of that, just to see some different things that happen. Cosine x equals 1/4, we're going to round to the nearest degree. So we start out the same way. We do a cosine inverse of 1/4 to get an answer. This is not a special angle value, so I'm expecting some sort of decimal, which I did get. So I got 76 degrees to the nearest degree. Now, this says cosine is positive, and I know cosine is positive in quadrant 1 and 4. 76 is my first quadrant answer, and then to get an answer in quadrant 4, we would do 360 minus 76, which is going to give me 294. So these are my two answers to the equation to the nearest degree. Moving on to the next one, now we have sine as a negative value. Okay, so before I even do this, I'm going to figure out those quadrant answers, and this is kind of the pattern you start to get into. So since sine is negative, I'm not in the positive quadrants, I'm in the negative quadrants. Now, when we do sine inverse, some weird things happen when I answer negatives, so I'm just going to put in a positive 1/3. And that's something you can talk more about in pre-calc. That brings in a whole other part with restricted domains and inverse functions, but I just type in the positive value. So my reference angle is 19 degrees. So that gives me a nice first quadrant answer, which is not what I want, but it's going to help me get into those other quadrants. So I circled quadrants 3 and 4. To get into quadrant 3, we do 180 plus 19, so I get 199. And to get into quadrant 4, we already know we do 360 minus the angle, so that's going to give me 341. So those are my two answers. Moving on to the next one. This is the same idea. I'm actually not going to go through and do this one, but basically just talking through it, I'd do a cosine inverse. I'd get of 1/3. I'd get the reference angle. And this time I would have crossed out 1 and 4. So it would be in quadrants 2 and 3. So if you wanted to try that one, you could work through that one. The last one, remember, this is just a taste of this, just a preview. Sometimes we do our answers in radians. So on this one, sine is positive. So we're in quadrant 1 or 2. Now, I can actually do this one fully without the calculator. Because if I say, when is sine equal radical 2 over 2? If I write that chart out for my special angles, I know that answer is 45, which in radians is pi over 4. So my first quadrant answer is pi over 4. We know the second quadrant answer is just pi minus pi over 4. Take away 4/4, take away 1/4 is 3/4. So that's really advanced if you can think in radians. If you can't, the suggested way is to just do the way we've been doing. So we would get 45. Then I have to think about what is 45 in radians, which would be the pi over 4, which we know from the chart. Then I could do 180 minus 45, which is 135, and then I could think about, well, what's on the unit circle at 135 in radians, but ultimately you do need to get to the radian answers. The next two on the last page are just one step up. So now we have some traditional algebra to do, some traditional algebraic manipulation before we do that last solving step with the trig angles. So we call this a linear trigonometric equation because there's no squares, right? So it's linear, we can just add and subtract and move stuff. So I want to get my cosines together, just like in this equation. Should be a 5 plus 15x. I'm trying to model the same equation using x's instead of cosine thetas. The first thing I would do is move the 8x over. Canceling, giving me 11 equals 5 minus 7x. So I'm going to do, or plus 7x. I'm going to do the same thing over here. I'm going to subtract and get the cosines together, giving me 11 equals 5 plus 7 cosine theta. Then I'm going to move the 5 over, just as I would move the 5 over here. And this is just a parallel regular equation so we can see the commonalities between the two. And then last thing I do over here is divide by 7. And the last thing I do over here is divide by 7. Well, not quite the last. The last thing I do normally to get to my final trig step. So with x, we're done. But we haven't really, we're trying to solve for theta here, and theta is not by itself yet. So we have to do the cosine inverse of 6 over 7. So second cosine of 6 over 7 is 31. And then we also, in the midst of all of this, can't forget about the fact that we have two answers. Cosine is positive So we're going to be in quadrants 1 and 4 in ASTC. So 31 is in quadrant 1. 360 minus 31, which is 329, is in quadrant 4. So that's called a linear trigonometric equation. Our last one, once again, just to preview, is a quadratic trig equation. So if I think about this with regular variables, x squared minus 6x plus 8 equals 0, I would find numbers that add up to -6 and multiply to 8. So that would be -2 and -4. And when we solve, we get 2 and 4. So with our trigonometric equation, now I'm going to be factoring, but instead of x and x, I'm going to have tangent theta and tangent theta. So we break it up the same way, because tangent times tangent equals tangent squared. And then we can do -2 and -4. So then when we solve, we get tangent theta equals 2 and tangent theta equals 4. Once again, we're not done because we're trying to solve for theta. Each of my equations, since we now have 2 equations, is going to give me 2 answers. So I'm actually going to end up with 4 different answers. I'm going to do tangent inverse. We'll start with this one. And they work separately. So I'm going to think about ASTC separately for each one. In this case, they're both positive, but I could have one positive and one negative. So tangent inverse of 2 is 63. First quadrant and third quadrant for tangent being positive. So that's 63 and 180 plus 63 to get into quadrant 3 is 243. So there's 2 of my answers. This one, second tangent of 4, is 76. And once again, we're going into 1 and 3 because 4 is also a positive number. So I have 76 degrees. 180 plus 76 is 256. So when you're in pre-calc, it does get a little harder than this. We do actually tie the identities into equations, but you would spend like 2 weeks working on this stuff. And this is just, hey, I've seen it before. So when you see, it's something to connect to when you're at the next level.